Welcome back to the classroom. My name is Mr. Wong, and in today's video we're going to be looking at a question for physics. I just won't go to the exact topic. It looks like circular motion, but it's actually looking at projectile motion. The 2022 HSC Physics paper. In this particular question, we have a hammer thrown in a sporting event. It's 7 kilograms. And it rotates in a circular radius of 1.6 meters, as you can see here, with a period of 0.5 seconds. Effectively, what that means, it takes 0.5 seconds for it to make one whole loop. It's released at point P, so it's coming out at like so, and it is 1.2 meters above the ground, where its velocity is 45 degrees to the horizontal. Okay, so in the very first question it says show that the vertical component, so let's change color just to highlight where it is. We're saying this component is 14.2 meters per second, so that's what we want to show. Now obviously this is circular motion. We're saying at this point here the person releases. And so what we know with circular motion, at all points, the object is moving at a tangent. So at this point, that's the tangent of its motion there. So let's have a look at what we need to do. Okay, assuming this is in uniform circular motion, then we can say that the velocity, in this case, or the initial velocity, we'll call that u, this is u here, is 2 pi r over t. 2 pi r represents the circumference of our particular circle, and then capital T represents the time it takes for it to rotate around. So it'll be 2 pi, our radius was 1.6 over a time of 0.5 seconds, and that means our overall velocity, let's see, was 20.0 or 20.106 19298 meters per second. But we want to find uy. So in this case, we need to use sine theta. So uy equals to u multiplied by sine theta. In this case, u is the value that we just calculated, and then we have sine 45 degrees, and that gives me an answer of 14.2172254, and so if I round that to the value there, that is 14.2 meters per second going upwards. So that's how you do the first question. We move on to question 2. It says calculate the horizontal range of the projectile from point P. Okay, so in order to find the horizontal range, there's a couple of things we need to know. The horizontal velocity, initial horizontal velocity, and also the time it takes for it to fall. To find horizontal range, the formula I need to use Sx to represent a horizontal range, ux multiplied by t. Now ux is relatively straightforward to find. It is our initial velocity of launch, but instead of using sine theta, we use cos theta. T, on the other hand, is a little bit more difficult, and we're going to try and solve for that first. So let's go through the actual theory behind it. When we release the projectile, it is 1.2 meters above the ground. It's going to go on its loop, and then it's going to come all the way down. Okay? So its starting position to its end position is about 1.2 meters in difference. So we've fallen overall by 1.2 meters. So that is what our overall change in vertical displacement will be. Okay, we're going to use the following formula because we want to find time. So S would be negative 1.2 because I'm going to say going down like this is negative. Our initial velocity in the vertical component is our value of 14. I'm just going to write the whole number here. It's just good practice to use the entirety of the number, and you don't round off until the very end. We have a value for t. We know that AY is negative 9.8. If we multiply that by a half, that's going to be negative 4.9 t squared. And now I'm going to rearrange the equation where t squared is a positive value, and so we get 4.9 t squared subtracted by 14.217224 t subtracted by 1.2, and that equals 0. So I think some of you can already predict what we're trying to achieve here, and that is to use the quadratic formula. So according to the quadratic formula, t is equal to the negative value of this component here, the b component. So it's negative, but the value is also negative, so it's actually going to end up becoming a positive value. But we'll leave that as that for now, just so you can see. Okay. Plus or minus, sorry, our value again of b, which in this case is 14. So there we have that. Squared subtracted by 4 multiplied by 4.9 multiplied by negative 1.2. That is then divided by 2 multiplied by 4.9. In case anyone forgot, how do we get to this particular values of numbers? It's minus b plus or minus b squared subtracted by 4 multiplied by c, and then 2a. And usually the way we write it is a squared plus bx subtracted by c equals 0. So you see where we're getting that formula from. Okay, so there's two values of time that I calculated. There was 2.98355708.9, or a value of negative 0.08. I didn't bother writing down the entire numbers of the negative value because obviously we can't have negative time. So what we have here is the time it's taken for it to go from launch and then to the bottom, falling at a distance of 1.2 meters overall. Okay. All right. So the last thing we need to do is now find the horizontal velocity. The horizontal velocity is u multiplied by cos theta. Theta, remember, is 45. And then you could write the entirety of the number of 14.2 blah 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 blah, well, not 14.2, 20.1 blah 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 blah. But let's just use the whole value of 2 pi 1.6 because it's just easier to write, no other reason. So 2 pi 1.6 over 0.5. So let's put that into our formula here. So 2 pi 1.6 over 0.5, that's the u. Now we have to times it by cos theta, which is 45, and then multiply it by the total time taken. And if I look at the overall distance, that is, where did I write? 42.41790.363, which if I round that off using the low sig figs used in this particular problem, which would be 2 significant figures, then my value would be 42 meters. And so that's how you solve our problem here. So you can see for 4 marks, that's quite a lot of working out, but hopefully you could also appreciate it's a really nice challenge. Instead of assuming it's just perfectly circular motion, there is also projectile motion into it. So it's a great question to go through. If you found this video useful and you haven't liked already, please do that, and subscribe if you haven't done so already. There'll be more videos to come. I'll see you next time.